Hi guys, this is the EdExcel GCSE 91 Maths Paper 1 from the higher papers, and this is from the June 2019 series, and it's a non-calculator paper. Question 1. There are only blue cubes, red cubes and yellow cubes in a box, and the table shows the probability of taking at random a blue cube from the box, and we see the probability of selecting a blue is 0.2. The number of red cubes in the box is the same as the number of yellow cubes in the box. We have to complete the table. Well, if the number of red cubes is the same as the number of yellow cubes, then the probability of selecting a red is the same as selecting a yellow. Let's call that probability x. So we have x over here and x over here. Now we know that probability adds up to 1. So the sum of probabilities is equal to 1, and using this information we have the probability of selecting a blue, that's 0.2, plus the probability of selecting a red, we said that was x, plus the probability of selecting a yellow, we also said that was x, and adding these three probabilities together we get a total of 1. And if we simplify all this, we have 2x which is equal to 0.8, and therefore x is equal to 0.4. And knowing that x is equal to 0.4, the probability of selecting a red is 0.4. The probability of selecting a yellow is also 0.4. And now for part B of the question, there are 12 blue cubes in the box. We have to work out the total number of cubes in the box. Well, if we know that the number of blue cubes in the box is 12, and that corresponds to a probability of 0.2, then what you can hopefully see over here, if here we have 12 cubes, which corresponds to 0.2, 0.4, which is 2 times by 0.2, will correspond to 24 cubes. So there's 24 red cubes, there's also 24 yellow cubes. And therefore, the total number of cubes in the box, that will be the 12 blue, plus the 24 red, plus the 24 yellow, which is 60. So we have 60 cubes in total. Now for question 2, Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar, 2 times as much butter as sugar. Dion is going to make 60 biscuits. We have to work out the amount of flour she needs. So for this question, for 15 biscuits, so let's just write this down, for 15 biscuits, we know that we require 50 grams of sugar, and we know that flour is 3 times as much sugar, so 3 times by 50, that's 150, so we have 150 grams of flour. And for butter, that's 2 times as much sugar, so 2 times by 50, that's 100, so we have 100 grams of butter which is required for 15 biscuits. And for 60 biscuits, therefore, hopefully you can see 60 is 4 times by 15, and therefore to work out the amount of each ingredient we need for 60 biscuits, we multiply each of these quantities by 4. So 50 multiplied by 4, that's 200. So for 60 biscuits we require 200 grams of sugar, 150 times by 4, that would be 600. So we require 600 grams of flour. 100 multiplied by 4, that would be 400. So we require 400 grams of butter for 60 biscuits. So the amount of flour she needs, that will be 600 grams. And for the next part, Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250 gram packs. And how many packs of butter does Dion need to buy? So for this question, we have the 250 grams already, which corresponds to 1 pack. And if we add on another 250, so this is another pack, this takes us up to 500. And we see already over here, we require 600 grams. So we need a bit more butter. So let's buy another pack of 250 grams of butter. So here we've got another pack. And therefore, you'd see here, we require 3 packs of butter. Question number 3, we have to find the highest common factor of 72 and 90. The way we can do this question is to first of all create a factor tree, and from that we can find the prime factors of 72 and 90, and then find the common factors from there, and then multiply those together. So two numbers which multiply to give 72, one of which is a prime number, we have 2 and 36. 2 is a prime number, 36 isn't. So the 36 we can further split up into 2 and 18. 2 is a prime number, 18 isn't. So 18 we can further split up into 2 times by 9. 2 is a prime number, 9 isn't. And the 9 we can finally split up into 3 times by 3, both of which are prime numbers. And if we consider this 90, two numbers which multiply to give 90, we have 2 times by 45. 2 is a prime number, 45 isn't. And 45 we can split up into 3 times by 15. 3 is a prime number, 15 isn't. So the 15 we can split up into 3 times by 5. So when we come to work out the highest common factor of 72 and 90, let's see what's common. We have the 2 over here and here, which is common. We also have a 3 here and a 3 here, which is common. And we also have a 3 here and a 3 here, which is common. And if we multiply these together, we get 18. For question 4, the diagram shows a plan, the front elevation and the side elevation of a shape drawn in a centimetre grid, and in the space below we have to draw a sketch of the solid shape. Give the dimensions of the solid on your sketch. Well, on the top we've got a circle with diameter of 4 units. Now the front elevation is the same as the side elevation, and on the top we've got this circle with diameter 4, and here we've got a length of 4 and another length of 4, and therefore if we combine these shapes together, hopefully you can see we've got a cylinder. So let's quickly draw a cylinder. We've got something like this, and if we add on the dimensions for the diameter of this cylinder, we've got 4 centimeters. And the reason I say centimeters, in the question we were told we've got a centimeter grid. And the height, we've got a height of 5. So if we add this height on, we have 5 centimeters here. For question number 5, shape A can be transformed to shape B by a reflection in the x-axis followed by a translation by vectors CD. We have to find the value of C and the value of D. Well, if we reflect shape A in the x-axis, we would have the following shape. Reflecting it in the x-axis, we have a length here and also another length here. Okay, so here let's call this shape A dash, and then to go from A dash to B, if we consider this point, the corresponding point is over here, we would have to go 1, 2, 3, 4, 5, 6 units to the left. So in terms of our translation, we have -6, and then we go 1 unit down, so we have -6, -1. So therefore the value of C, that's -6, the value of D, that's -1. Question number 6. A shop sells packs of black pens, packs of red pens and packs of green pens. There are 2 pens in each pack of black pens, 5 pens in each pack of red pens, 6 pens in each pack of green pens. On Monday, the number of packs of black pens sold to the number of packs of red pens sold to the number of packs of green pens sold, that's given by this ratio 7:3:4. A total of 212 pens were sold. We have to work out the number of green pens sold. Well, first of all, knowing how many pens are in each pack, we can first of all find out the ratio of pens sold. So for the ratio of pens sold, what we have over here is the black to red to green. Well, so far we know we've got 7 packs of black, and then we've got 2 pens in each black pack, so 2 times by 7, that will be 14. We've got 5 pens in each pack of red packs. We've got 3 red packs, so 3 times by 5, that will be 15. And we've got 6 pens in each green pack, and we've got 4 green packs, so 6 times by 4, that's 24. So what we see here, that the ratio of pens sold, let's just underline this, that's given by 14 to 15 to 24. Now we know that we have a total of 212 pens which were sold. So with this we can find out the number of pens per part. So before that we need to find out the number of parts we have. So the number of parts, that will be 14 plus 15 plus 24, which is 53. And therefore the number of pens per part, that will equal 212 divided by 53, which is 4. And therefore the number of green pens sold, so therefore the number of green pens sold, that's equal to 24 multiplied by 4, which is 96. So we have 96 green pens which are sold. For question 7, we've got two rectangles over here. QR is equal to 10 centimeters. Let's add this to the diagram. So we've got 10 centimeters here, and therefore because we've got a rectangle, the length PS will also be 10 centimeters. We know that BC is equal to PQ. So BC is equal to PQ. So if we say that the length PQ is X centimeters, we can therefore conclude BC is also X centimeters. And because we have a rectangle, SR is also X centimeters, and AD is also X centimeters. The perimeter of ABCD is 26 centimeters, and the area of PQRS, that's 45 centimeters squared, and we have to find the length AB. Now we don't know what AB is, but if we call this length Y centimeters, because we have a rectangle, DC will also equal Y centimeters. And if we consider the rectangle PQRS, we know that the area is 45 centimeters, so we have 10 centimeters multiplied by X centimeters, which is 45 centimeters. So we have 10X, which is equal to 45, and therefore X, that's equal to 4.5. So if we now consider the rectangle ABCD, the perimeter is 26, so therefore we have X plus Y, which is 26. In other words, we have 2X plus 2Y, that's equal to 26. Now we know what X is, that's 4.5. So 2 times by 4.5, that will be 9. So we have 9 plus 2Y, which is equal to 26. 2Y, that's equal to 17. And therefore Y, that's equal to 8.5. And if you remember, we said that Y represents the length of AB. So therefore, the length of AB, that's 8.5 centimeters. Question 8, we have to work out an estimate for the square root of 63.5 times 101.7. Now for this question, we would have to first of all round these numbers. Now because we're square rooting, let's find numbers which are square numbers. Of course 63.5, that's almost 64, and 64 is a square number. So this result is approximately equal to the square root of 64 multiplied by, here we can approximate this as 100. So if we work all of this out, of course we can split this up using the laws of surds. We can split this up as root 64 times by root 100. Root 64, that's equal to 8. Root 100, that's equal to 10. Turns out the approximation for this is 80. For part B of the question, 2.3 to the power of 6 is equal to 148. Correct to 3 significant figures, and we have to find the value of 0.23 to the power of 6, correct to 3 significant figures. Well, you'll notice the 0.23 is 10 times smaller than the 2.3. So we can rewrite this result as 0.1 times by 2.3 to the power of 6, which, using the laws of indices, we can rewrite as 0.1 to the power of 6 multiplied by, 0.3, multiplied by 2.3 to the power of 6. Now 0.1 to the power of 6, that's the same as 1 times 10 to the minus 6. And then the 2.3 to the power of 6, correct to 3 significant figures, that's 148. And if we multiply these two together, we get 0.000148. Okay? So here we have 0.000148. And now for part C of the question, we have to work out the value of 5 to the power of minus 2. Again, using the laws of indices, 5 to the minus 2, that's the same as 1 over 5 squared. So here we have 1 over 25. Question 9, we have to work out 3.5 multiplied by 1 3/5, and we have to give our answer as a mixed number in its simplest form. The first thing we can do, we can rewrite these numbers as top-heavy fractions. So if we do that, 3.5, to convert that into a top-heavy fraction, we have 3 times by 2 plus the 1, and then we divide this result by 2, and then the 1 3/5 we can also convert to a top-heavy fraction. We have 1 times by the 5 plus the 3, and then we divide this by 5. So here on the top we get 6 plus 1, which is 7. So we have 7 over 2 multiplied by, well, here we've got 5 times by 5 plus 3, which is 8. So we multiply by 8 over 5. So it turns out we get 56 over 10. Now 10 goes into 56 5 whole times, and what's left over is 6. So we have 5 and 6/10. And 6 over 10 we can simplify to 3/5. So our final answer, we have 5 wholes and 3/5. For question 10, the graphs with equations 3y plus 2x equals a half and 2y minus 3x equals minus 113 over 12 have been drawn on the grid below. And using the graphs, we have to find estimates of the solutions of the simultaneous equations 3y plus 2x equals 1/2 and 2y minus 3x equals minus 113 over 12. So over here we have to look for the intersection point, and if we grab a ruler, in terms of the y coordinate we've got something around here, and in terms of the x coordinate we have something around here. So let's just draw this line on. So these points over here, we've got here 2.225. So here we've got 2.225, and here we've got minus 1.3. So we see we have an x solution of 2.25, and here a y coordinate of minus 1.35. Question 11. A bus company recorded the ages in years of the people on coach A and the people on coach B. Here are the ages of the 23 people on coach A, and we have to complete the table below to show the information about the ages of the people on coach A. Well, over here we would have to find the median, the lower quartile and the upper quartile, and we have 23 pieces of data. So 23 plus 1 divided by 2, that will be 12. So the 12th piece of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that's 59. So the median therefore is 59. And 12 divided by 2, that would be 6. So the sixth piece of data, 1, 2, 3, 4, 5, 6, that would be 53. So therefore the lower quartile, that's 53, and then 12 plus 6, so 12, 13, 14, 15, 16, 17, 18, that will be 66. So the upper quartile is 66. And over here we've got some information about the ages of the people on coach B, and Richard says that the people on coach A are younger than the people on coach B. Is Richard correct? You must give a reason for your answer. So for this question, we can compare the averages. So we can compare the median from A with the median on B. And if we do that, we can see that he is correct because the median of A, which is 59, is less than the median of B, which is 70. And now for part C of the question, Richard says that the people on coach A vary more in age than the people on coach B. Is Richard correct? Well, for this question we can take a look at the interquartile range. And if we work out the interquartile range of A, upper quartile take away lower quartile, that's 13. And over here, interquartile range for B, that's 73 take away 54, which is 19. So the interquartile range of A, which is 13, is less than the interquartile range of B, which is 19, so therefore is incorrect. For question 12, we've got three spheres here, P, Q and R, and the volume of Q is 50% more than the volume of P, and the volume of R is 50% more than the volume of Q, and we have to find the volume of P as a fraction of the volume of Q. Now, to do this question, to go from P to Q, we multiply by 1.5. The reason for this, it's 50% more. So as a multiplier, 50% more implies 150%. So we multiply by 1.5 to go from P to Q. Similarly, from Q to R, we would also have to multiply by 1.5. Okay. So, for this question, if we say that the volume of P has volume of 100%, then as a regular number that will be 1. So let's just call this 1 unit cubed. Okay, and if we multiply by 1.5, for Q we have 3 over 2 units cubed. And if we multiply 3 over 2 by 1.5, we get 9 over 4 unit cubed. And therefore, as a fraction, we have 4 over 9, because P over R, essentially, that's equal to 1 divided by 9 over 4, which is 4 over 9. So we have 4 over 9. Question 13. Given that n can be any integer such that n is greater than 1, we have to prove that n squared minus n is never an odd number. Well, if we factorize n squared minus n, we end up with n lots of n minus 1. And what you see over here, n lots of n minus 1, that's the product of two consecutive integers. Now, if we have two integers which are consecutive, one must be odd and one must be even. And that's what I've written over here. One integer must be odd and the other integer must be even. And therefore, if one must be odd and the other must be even, we see over here we have a odd number multiplied by an even number, which is even. And therefore, in conclusion, n squared minus n is never an odd number. Question 14, we have to find the exact value of tan 30 degrees multiplied by sine 60 degrees. We have to give our answer in its simplest form. Tan 30, that's the same as root 3 over 3, or the same as 1 over root 3. Sine 60, that's the same as root 3 over 2. And if we multiply these together, root 3 times by root 3, that's 3. 3 times by 2, that's 6. Indeed, we get 1/2. Question 15. The diagram shows a solid shape, as shown here. The shape is a cone on top of a hemisphere. The height of the cone is 10 centimeters. The base of the cone has diameter of 6 centimeters, and therefore we can conclude over here its radius is equal to 3 centimeters. The hemisphere has a diameter of 6 centimeters again. The radius is 3 centimeters. And the total volume of the shape is k pi centimeters cubed, where k is an integer, and we have to work out the value of k. So for this question, we can treat the cone and the hemisphere separately. First of all, we've been given the formula for the volume of a cone and the formula for the volume of a sphere. Noticing that a hemisphere is half sphere, the volume of a hemisphere, that's equal to 4 over 3 multiplied by a half, which is 2 over 3 pi r cubed. So the volume of the cone, that will be 1/3 times by pi times by r squared, so we have times by 3 squared multiplied by the height, which is 10. So here we come out with 30 pi centimeters cubed, and the hemisphere, we have 2/3 multiplied by pi multiplied by 3 cubed. Turns out we get 18 pi centimeters cubed, and therefore the total volume, that's equal to 30 pi plus 18 pi, which is 48 pi centimeters cubed. In other words, k is equal to 48. Question 16. There are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4 or 5. The 3-digit number 553 is one way the dials can be set, as shown in the diagram. We have to work out the number of different 3-digit numbers that can be set for the combination lock. So for this question, now in this question we need to recognize that there's we've got 3 different dials on the combination lock. So for the first dial, we can either choose the numbers 1, 2, 3, 4 or 5. The second dial, we can choose either the number 1, 2, 3, 4 or 5. And for the third dial, we can either choose the number 1, 2, 3, 4 or 5. So if you think about it, for the first dial, there's 5 different numbers we can choose from. For the second dial, there's another 5 different ways we can choose from. For the third dial, there's 5 different ways we can choose. So multiplying these together, we end up with 125. For part B, how many of the possible 3-digit numbers have 3 digits? Well, for this one, for the first dial, there's 5 different ways of choosing the numbers. For the second dial, if I've already chosen one of those numbers, let's suppose I've already chosen the number 4, that means that there's 4 numbers left. So there's 4 different ways of choosing for the second dial. And for the third dial, if I've chosen 2 numbers, let's suppose I've chosen the number 1 and the number 4, there's 3 numbers remaining, and therefore I've got 3 different ways of selecting those numbers. Okay, so in conclusion, multiplying those together, we end up at 60. So there's 60 possible ways. Question 17, given that the ratio of x squared to 3x plus 5 is equal to 1 to 2, we have to find the possible values of x. Well, over here, if we express this as a fraction, x squared over 3x plus 5, that's equal to 1 over 2. And if we multiply the x squared by 2 and the 1 by 3x plus 5, so we've got 2 lots of x squared plus 1 lots of 3x plus 5. If we simplify all this, we end up with 2x squared equals 3x plus 5. And if we tidy this up, we've got 2x squared minus 3x minus 5 equals 0. And for us to solve this quadratic equation, we can factorize it. Of course, we require 2 numbers which multiply to give minus 10, which add to give the minus 3. You'd find those 2 numbers to be minus 5 and 2. So we can rewrite this minus 3x in terms of the numbers which we've just found. So we've got 2x squared plus 2x minus 5x minus 5 equals 0. And if we split this up into 2 parts, here we've got a 2x as a common factor, so inside a bracket we've got an x plus 1. We've got a minus 5, which is a common factor, and inside the bracket we've got an x plus 1, and all this is equal to 0. And grouping the terms together, we've got 2x minus 5 lots of x plus 1 equals 0. And therefore, either 2x minus 5 is equal to 0, or the x plus 1 is equal to 0. So therefore we've got x equals 2.5 and x equals minus 1. So therefore x is equal to minus 1 and 2.5. Question number 18, we have to express root 3 plus root 12 in the form a plus root 3, where a is an integer for part A of the question. So we've got this root 3 so far, and the root 12 we can rewrite as root 4 times by root 3. The reason I want to do this is in the question we've got a root 3 as a final answer. Now root 4, that's the same as 2. So we've got root 3 plus 2 root 3. Altogether we get 3 root 3. So therefore a is equal to 3, and therefore our final answer, that's 3 root 3. Now for part B of the question, we have to express 1 over root 3 all to the power of 7 in the form root b over c, where b and c are integers. So for this is the same as 1 to the power of 7 divided by root 3 to the power of 7. Now root 3 to the power of 7, let's just work this out on the side. Root 3 to the power of 7, that's equal to root 3 multiplied by itself 7 times. Okay, so we've got root 3 times 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 by root 3 times by root 3. Root 3 times by root 3, that's 3. Root 3 times root 3, that's 3. And root 3 times by root 3, that's also 3. And then we still multiply by the extra root 3 that remains. So we end up with 27 root 3. So what we have over here then is 1 to the power of 7, which is 1, and then root 3 to the power of 7, that's 27 root 3. So multiplying the top and bottom by root 3, so we have to multiply the top by root 3 and the bottom by root 3. We end up with root 3 divided by 27 times by root 3 times by root 3, which is the same as 27 times by 3. So we have root 3 over 81. So our final answer, that's root 3 over 81. Okay? Question 19. Given that x squared minus 6x plus 1 can be written in the form x minus a all squared minus b for all values of x, we have to find the value of a and the value of b. Well, this form over here suggests to us that we have to complete the square. So if we complete the square, halving the coefficient of x, so we have x minus 3 all squared, we subtract off the square of 3, and then we still have this plus 1. So we have x minus 3 all squared minus 9 plus 1. So we have x minus 3 all squared minus 8. And hopefully you can see here a is equal to 3, b that's equal to 8. And now for the next part of the question, hence write down the coordinates of the turning point of the graph y equals x squared minus 6x plus 1. Well, if we've been given this x minus a all squared minus b, if we've been given an equation in that form, we can therefore conclude that the turning point has coordinates a minus b. So therefore the coordinates of the turning point, we have 3 minus 8. Question 20. H is inversely proportional to p. P is directly proportional to the square root of t. Given that h equals 10 and t equals 144 when p equals 6, we have to find a formula for h in terms of t. Well, if h is inversely proportional to p, we have this. In other words, h is equal to some constant, let's call that constant a, over p. And if we know that p is directly proportional to the square root of t, we've got p which is directly proportional to the square root of t. So in other words, p is equal to some constant, we'll call that b, lots of the square root of t. Now, when t equals 144, p is equal to 6. So when t is equal to 144, p is equal to 6. So we have 6 equals b times by the square root of 144. So we've got 6 equals 12b. In other words, b, that's equal to 1/2. And knowing that b is equal to 1/2, we can conclude p is equal to 1/2 times by the square root of t. So if we substitute this into here, we've got h equals a over p. So we have h over 1/2 times by the square root of t. So therefore we have 2a over the square root of t. And we also know when t is equal to 144, h is equal to 10. So when t equals 144, h is equal to 10. So we have 10 equals 2a divided by the square root of 144. So we have 10 equals 2a over 12. So therefore 2a, that's equal to 120. In other words, 10 times by 12. And knowing the value of 2a, we can replace the 2a with 120. We can therefore conclude h is equal to 120 over the square root of t. So therefore, h is equal to 120 over the square root of t. Okay. Now for question 21, so for question number 21, the functions f and g are such that f of x is equal to 3x minus 1 and g of x is equal to x squared plus 4. We have to find the inverse of f. So to find the inverse, we first of all replace the f of x with y. So we've got y equals 3x minus 1. We then rearrange for x. So we see that x is equal to 1/3 lots of y plus 1. We then swap the x and y's. So we've got y equals 1/3 lots of x plus 1. We then replace the y with the inverse of f. So the inverse of f is equal to 1/3 lots of x plus 1. So we've got 1/3 lots of x plus 1. And for the next part, we have to show that f of g of x is equal to 2 lots of g of f of x. Well, for f of g of x, we substitute in the g of x into f of x. In other words, we replace the x with what g is. So we've got 3 lots of x squared plus 4. And on the other side, we've got 2 lots of g of f of x. So we've got g of f of x. In other words, we replace the x over here with f. So we replace the x with 3x minus 1. So we've got 3x minus 1 all squared plus 4. So let's tidy all this up. We've got 3x squared plus 12. Sorry, and here we've got a minus 1. And this is equal to 2 lots of 9x squared minus 6x plus 1 plus 4. So we've got 3x squared plus 11. This is equal to 2 lots of 9x squared minus 6x plus 5. So we've got 3x squared plus 11. This is equal to 18x squared minus 12x plus 10. And if we take everything over to one side, in conclusion, we have 15x squared minus 12x minus 1 equals 0. For question 22, there are only R red counters and G green counters in a bag. A counter is taken at random from the bag. The probability that the counter is green is 3/7. The counter is put back in the bag. 2 more red counters and 3 more green counters are put in the bag. A counter is taken at random from the bag. The probability that the counter is green is 6/13. We have to find the number of red counters and the number of green counters that were in the bag originally. Now, if we consider this first statement, we've got red counters and green counters only originally. So therefore, the total number of counters we've got will be R plus G. And if we select a green counter, the probability of selecting a green, that's equal to 3/7. So all this over here would correspond to this statement over here. And then we see that 2 more counters are put in, 2 more red counters are put in the bag and 3 more green counters are put in the bag. So the total this time would be R plus G plus 5. Because we've got the 2 plus the 3, which is 5. And now the probability of selecting a green, so the number of green we've got this time will be G plus 3. And all this is equal to 6/13. So this statement over here corresponds to this over here. And we have to find out the number of red and the number of green. In other words, we wish to find out what G is and what R is. So if I call this equation 1 and this equation 2, from equation 1, we've got 3G, which is equal to 3R plus 3G. Sorry, we've got 7G. In other words, 4G is equal to 3R. We'll call this equation 3 for now. And if we look at this bottom equation, we've got 13 lots of G plus 3. So here we've got from equation 2, we've got 13g plus 39. This is equal to 6 lots of r plus g plus 5. So we've got 6r plus 6g plus 30. Okay, 6 times 5 is 30, 6 times g is 6g, 6 times r, that's 6r. And if we tidy all of this up, it turns out we get over here 7g, that's equal to 6r minus 9. Okay, we'll call this equation 4. And if we take a look at equation 3, we can now solve these equations simultaneously, equation 3 and 4 simultaneously. From equation 3, we can multiply by 2, so we end up with 6r equals 8g. And now we can replace this 6r with 8g. So if I call this equation 5, and now substitute in 5 into 4, we've got 7g equals 8g minus 9. In other words, g, that's equal to 9. So the number of green counters is 9. So, knowing that g is equal to 9, substituting into equation 3, we've got 4 times by 9, which is 36. And this is equal to 3r. In other words, r, that's equal to 12. So we've got 12 red counters. So that concludes the end of the paper.